Okay, that should be on now.
Yep.
Tom, do you want to put your mic in?
Oh, yeah, yes. Seconds, and I will be with all of you guys.
You're the cool kid at the back there. Gonna cause trouble. Heckle me.
Welcome everybody. My name is Tom Breza. Welcome on the third class of CPP London Uni for our second course. So first of all, I would like to say a big thank you to Justin, Oliver, who is present in spirit. He's just traveling back from holiday, and company Mindcast for their kindness and giving us this space for free. Really appreciate it. They're very big friends of ours. Thank you very much to Tristan, our teacher. He's today not his best. He got some viruses attacking him, but he's coming here and fighting.
I've got some Coca-Cola. That fixes everything, right?
Yeah. Don't try to drink
Sugar
it.
and
You end up with the same
Yeah.
viruses. So Tristan is testing you. First of all, did everybody connected to Wi-Fi? Yes,
You will need it for today, so probably.
Good, you will need that. Now, a small update. I'm really sorry about the delay with the licenses. The JetBrains basically is getting us 6 months licenses, and then if you want to continue, then they will give you a discount if you want to buy, or you can use I suspect the version which you had the license for. But the person who gets the licenses for us, Phil Nash, he was extremely busy. He was going to CPP now.
Oh, CPP now.
CPP now, yeah. So he's back and forth between airplanes and traveling and so on, and he didn't manage to get the update. I was chasing him yesterday and today, and he replied that look, I'm just pushing the person inside, and as soon as we get it, I will. I have your emails, so I didn't forget about you. But as soon as I get it, you will know. I will send you the email. What else do I need to tell you? Now, as standard, please put your name clearly. Name, surname, if you want to be on our website. Now, small request. This is bad of me. I'm really sorry. If you've been on the previous class, put number 2 next to your name. Somehow, somewhere, I just take this piece of paper. This time I'll take a photo, and I can't find it. And I'll find it when I don't need it. But for now, if you wouldn't mind to just put your name and the number 2 if you were on the previous class. So refill the stuff, and I'll put you as well there. Now, very important, we are looking for sponsors. We're looking for probably a bigger business, yes, like Mimecast, somebody, like a bigger company who would like to do something good for, community, and it would help try to work out with us something which we can basically translate in providing you with the classes. So if you work for a bigger business, or if you know somebody who might be interested, let them know, yes? Send them into our directions. As you can see, we're doing this, as unpaid. And, even getting that kind of venue, sometimes it's very difficult, A venue like this can cost on its own something like £800. Yeah, and sometimes it's a struggle. So what we're looking is we're trying to stay in one place as much as possible to not to cause confusion for you, because we have people turning up different sites and then they're getting cross because they didn't read or they didn't get the message. So if we can stay in one place, it's better for everybody and obviously help you as well. So if you know anybody, let us know. Feedback. Let us know. If we do something good, fine, let us know. It's good for morale. But if we do something bad, or you think we could do better, that's the very much more important. Because if I assume I'm doing everything perfect, I'm not looking for a way of improving. If you think like, Tom, we could do that maybe better, or this is not perfect, I won't know. So let me know. It's like if you have a big painting, yes, and if you're looking at the small picture, as we are, yes, me, Tristan, Ollie, at some point we'd stop seeing the big picture. You're coming with the fresh eyes. You can say, actually, this is rubbish. So let us know. Now another thing which come out. Again, please check our website. Our website. Who knows our website address? Hands up.
Yeah.
Almost everybody. Okay. Our website is cpplondonuni.com. Yes. Why it's important? Because we have people. Yes. There's lots of information about us. Sometimes from us. Sometimes not from us. And we don't always have a control what sort of information. Sometimes you might go somewhere where it's outdated information because something changed. Like we had the class which was at King, the last class. That class is supposed to happen at Skills Matters, but Skills Matters said, "Really sorry guys, we can only give you 20 spaces maximum." And I said, "Well, we have over 50 people, so we can't. Sorry." And we had people who turn up at Skills Matter and were quite cross. So go to our website. Check what's happening there because we will try to put the most up-to-date information. Same for Twitter. Check on my Twitter account. If there's any changes on the quicks, I'll try to publish there. Now, we're looking for a volunteer. We're looking for someone who is good with the website design. Our website is a big pile of Wix.
It's quirky.
It doesn't really work exactly the way we would like. Yes, they've got certain teeny nigglets which we don't like. And if somebody is willing to help us to rebuild, come to me, tell me, and we'll sit down and we'll tell you what we need. And then let's build the website.
I mean, we are aware that half the people in the room are programming JavaScript, so half of you have got no excuse.
I was going to say, Tom, if Giacomo asks Alex to do it, I'll second that.
Well, what I was
Come
thinking,
on, Alex,
what I
you
was
can do
thinking
it.
actually is perhaps we can get, perhaps we can put it to the members of Co-Academy London as well.
So to do what?
To members of Co-Academy London as
Uh-huh.
well. Because they are web-based.
I think the voice always going down.
I mean, yeah, we're looking for someone who, I mean, we don't mind if they put their logo or something so they got credentials as well from that. Yes,
Yeah.
we do understand that. But if we can go,
Yeah.
something better than Wix, yes. Wix is okay, yeah, but it's not okay most of the time. It is for your comfort. So if you can help, yes, if you can coerce someone in gently, yes, without breaking their arms too much, let me know. Okay, now, next week will be very important class. At least the beginning will be very important, especially for me. I hope. There will be announcement who passed. I hope I will. Who passed the first edition of the course? So we'll take a few minutes, and the people who passed, they will be given a diploma from Tristan and Ollie. Because I'm one of the people who was taking the part, so I'll be sitting on your side, not on the other side. But the idea is basically these guys who will get a little bit of prize, if they passed. And the same will be happening for you if you stay with us, if you learn enough, and you decide to take a test at the end. Yes, basically you have to build a program and explain how it works. So obviously support these guys when they come, and hopefully they pass. The last thing, and then I'm passing you to Tristan. He will tell you way more interesting stuff. Because we're using this space, due to the kindness, we need to make sure this place is spotless. Yeah. So when we're leaving, can you ensure it's clean? There's no rubbish and so on. Otherwise, if we leave broken things and so on, we might not get that place again, and you might see my headless body somewhere by the river. So that's all from me. I'm passing you to Tristan.
All right. Well, good evening again, everybody. Thank you for bearing with us while we've been moving around different places. 3 weeks, 3 different locations. We're aware it's not ideal. We're doing our best, as Tom said, to sort it out, to try and find somewhere permanent. But with such a big group and meeting weekly, it's quite a tall order for companies to commit to giving us this space for nothing. So, as Tom said, we do appreciate Mingcast stepping in this week, and Justin, who's sitting right there for dealing with everything, with Ollie being away. So thank you to Justin. Thank you to Mingcast. Right. Let's actually get started with things. This is the same first slide that you would have seen last week and the week before, and the people who came here before would have seen it hundreds of times. We do like to hear from you, not only, as Tom said, for feedback, but also just if you've got questions about the material, about C++ in general. The best way to talk to us is on Slack. As I say, you've all, or most of you, I think, have been to one of the last 2 sessions, so you've probably already seen this, but if you haven't, go to that website, pop your email address in, it'll send you an invitation, because it's very exclusive, you just put your address in, right? It'll send you an invitation to join the CPP Lang Slack channel, and then we've got our own room in there to talk about our stuff. So please do that. Second standard slide is about this weighty tome. Anybody who doesn't have a copy, we're going to be, not this week actually, but we will be making use of it in future. So if you have your own copy, it'd be very handy. Whether it's the physical book or an ebook, that's up to you. Right. So last week, nearly everybody was here last week. I think I recognise a lot of faces anyway. We didn't quite cover everything that I had prepared. We had a nice break for some pizza and beer, which was wonderful. But it meant we didn't quite cover as much as we wanted to, but that's okay, because we've still got plenty of time and we'll catch up. But these are the things that we did. Has anybody got any questions about the stuff we did cover last week before we move on? I know I've had a couple of questions already, but anybody else got anything that's really perplexed them? I know it doesn't help that I didn't upload the slides till this morning, so apologies for that. That was my bad. Sorry. But no, excellent. I did a really good job then. Awesome. So this week, this is what's on the menu for this week. First of all, we're going to get everybody set up with a compiler with an IDE called CLion. And then we're going to talk about, we're not actually going to learn any new C++ this week. Or not directly anyway. We're going to learn about how C++ compilers work, how you physically put together C++ programs. So it's more sort of about the language rather than actually directly learning any new syntax or any new features today. That said, if we run out of time, I do still have the material we didn't cover from last week, so if we do run out of time, there's still plenty to do, so don't worry about that. So far the first couple of weeks we used OneBox. It's an online compiler. You put your source code in, click a button, and it shows you the output, which is fine for little examples, but obviously you can't write real programs that way. So our first goal today is we want everybody set up with a working compiler and a working IDE. Now, we're going to use CLion because it's pretty good. It's very good, in fact. It's available everywhere. It's available Windows, Mac, and Linux, and it lets us all sort of be on the same page. So when I'm if I'm doing demos on the screen, you can see exactly what I can see on your screen, hopefully. And as far as compilers go, we'll talk about it later. There are really 3 that matter. We're going to be using either GCC or Clang. So, guess a show of hands. Who has already got CLion all set up and working? Okay, maybe half the group or so. Okay, well, you can relax, have some pizza. Oh, well, wait for me to finish the sentence first. Come on. What was I saying? Yes. So you guys can relax for a little while. For people who haven't, these are your instructions. Sorry, the text is a bit small. But if you have any problems, put your hand up, and either me or Tom or Justin or any one of these other very knowledgeable people will come around and do our best to help you. So we've got 2 steps. The first step is installing a compiler. The second step is installing CLion. These are the compiler instructions for various platforms. So once we've done that, I'll put up the instructions for installing CLion. Does that make sense?
Yes.
Does that not make sense to anybody? I meant
Equally,
no response
it makes
either
sense.
way, so I'm not really sure. But
That was a confusable reply.
Okay, well, these are your instructions, ladies and gentlemen. Please go ahead.
If anybody needs help, just raise the hand, and people who've done some C++ will try to go and give you a hand.
This one is the
Okay, so that's step 2 is CLion. You can go ahead and do that if you like. So, if you've already got, it needs to be set up.
but I don't know.
As promised, I'm taking
Oh,
photos.
no, sorry. For anybody who is using a Mac, that's supposed to be a double a dash. The fonts in CLion has merged them into a long dash, but it's supposed to be 2 separate dashes. Xcode select dash dash install. You've already got them. Excellent. Right, so let's just open this image.
Sorry, yeah, I was down over it. I didn't want it.
I can't see it.
You can maybe open YouTube if you want. That will help you maybe.
Maybe you can see it. There is a sequence. There is help you, sorry.
Oh, you've already got CLion installed. Tristan, I've already found out how this relates.
Tristan, can you do slightly bigger than
No, because that's as much as I want to put all 3 on.
Okay. It's the people on the back, if you're struggling to see, yes, if it's too small for you, open YouTube, yes, kick it, and then you have a full screen. You can maybe see easier, or that will save you the trip going to the front.
Alright. Well, no, because I don't want. Nobody's using either, so I'll take the next instructions off. But people need them.
Yeah.
Do we need to send ourselves with the CMake?
Yes, we do. To a little extent, you need to be aware of what it is, but I will talk about that.
Okay, right.
For the most part, CLion will handle it for you.
I'm trying to figure out.
There's a chair there. Nobody was sitting there. That's why I took off. So it's on my chair. Oh, that was amazing.
Switch it to
Point you there.
No, he detected automatically.
Yeah, I'm not sure. We're on Windows.
Yeah. The water is
No, so on Windows, if you download that, if you run the executable, it unbundles everything into a directory. That's all you need to do for this step. So it should be nice and easy on Windows. So if you want to install a compiler, you can Which one should we be using for this? Really, Clang or GCC. So you can, if you drop down there, to tell it about the So I don't know if you've installed GCC via home, could you tell it the path to your GCC?
Yeah, I think I
no,
GCC. It's on
yeah, but that's actually Apple's a bit naughty on it.
Oh yeah.
They type code GCC on the Mac is actually an alias. Because Apple used to use GCC, and so they've got so many people have their old make files just referred specifically to GCC. So when Apple moved to using Clang, they put this alias for GCC on there. So they have yeah, okay, so you haven't got the actual GCC. It doesn't matter, Clang's better in some ways.
Okay.
It's okay.
Yeah, I noticed it comes up with different things, different files, things different. It doesn't allow me to do initialize jars.
Oh.
I tried to use
Because you're not, if you put a letter in there,
For people running clients, it's lowercase cc. Yeah, it's not uppercase cc.
no, it's an uppercase CC.
Is it uppercase?
Definitely uppercase
Because on
CC.
this one it's on uppercase, the lowercase does.
Yeah, lowercase is the C compiler.
Uh-huh.
Uppercase is the system default C compiler. Uppercase is the system default C++ compiler. So yeah, it's because you're giving it. You're not actually giving it an empty character. You're not actually giving it a character, but now you're giving it the space character.
Kind of, yeah. It's just a little bit alien to me coming from a different language
Yeah,
where I can just put something in.
So that's a single character. But if you gave it a string, then empty things work because strings always have a null character at the end.
So you can have
that does
you can have MingGW, or you could have what's it, MingGYS.
So there are three on Windows. You're using Windows, right?
Yeah.
Yeah. So there are three. We'll talk about this in a minute.
Oh, okay. I don't want to jump the gun.
What's happened here?
Just calm down.
Who helped me getting this up and running in the first place? Sorry.
You'll have to use the live size window.
That's the one.
Yeah.
Which button is it?
You literally just navigate through.
Okay.
It's got like its own menu.
So yeah, there are three compilers that matter, which is Visual Studio compiler, GCC, which on Windows is called MingGW, for other reasons, and there's the other one, Clang. Clang works on Windows, but unfortunately CLion can't use it on Windows. It can on other platforms, just not on Windows yet. They're going to add it. So
If I have all three.
if you have all three, that's great. You can, if you don't mind doing it manually, you can test your code with all three, which is a really good thing to do.
We'll launch it now, right? I mean, now it's finished.
Yeah, so now if you go to applications,
So do I need to?
Yeah, I just read
yeah, so if you
It's not one.
This doesn't work.
So if I might jump on the gun here as well. So if I want to go for this one, I can just put it in here and then link it in.
So that's the one, and then if you,
So I need a subdomain.
yeah,
Shit.
that's okay.
I don't need to in-house TP there. I shouldn't. Yeah, okay.
If you just click OK, just to make sure it works.
So it should find. Okay, that's all right, isn't it?
Detect it. Yeah.
So that's applied. So now, so basically, I'm ready to rock and roll.
You are.
Those quick data.
Well, we'll have a proper check in just a moment.
Yes.
Oh, sorry.
If we put this.
No, that's GCC. That's the C compiler. So we used to make sure G++.
Okay. Because I don't.
Because on Linux, they often put them in separate packages, so you can download the C compiler without C++.
So I'm getting installed G++.
I think it's, I can't remember what it's called on Ubuntu. I know on Fedora it's called something like GCC-C++. That's why I didn't put. In Linux, it's all different depending on which distro you use. It's very annoying.
Sorry. Do I not import setting or custom validation?
I would say don't import settings just to start from that.
So do you guys use and that would be used as
No, so CLion is a text editor that you can put lots of plugins in. Yeah, so this is like a proper integrated development environment. So, help you out by highlighting the code, give you little underlines when you're using something. So yeah, choose whether you prefer light or dark. Builds tool chains. So it's alright, it's set it all up for you. Yep.
okay, so yeah,
You can always install these later. So
feature.
yeah, so just work your way through it. Okay, has everybody completed the installing a compiler step? No? Okay, seeing.
This first because you want to forget and
Have you downloaded it?
Yeah. I have it.
Okay, you've done it for step one.
Okay.
Yeah.
So all you have to do for Windows, all you need to do for this step is just extract that.
Yeah, sure.
Wherever you like, CMake.
Did you say you uploaded the slides from last week?
I think they should be on GitHub. They're not? Yeah, so
it used to be you on that good.
Yeah.
Last year's.
I tried to.
May have done.
Let's have a look.
Excuse me just a second, ladies and gents.
Last year's not been updated, so.
Oh yes.
Okay. Oh, right.
Did you press upload and then walk away? Suspend your machine?
I've just checked and it says my local Git is up to date.
No, because that's only for. I was only going to take a little catch up.
It's alright. I'll just do it again, I don't know what happened.
Okay, I installed the CLion first.
Alright.
Now I install
Alright, it's definitely there now.
Yeah.
Thank you. Because I installed CLion my own last week and then I installed this
MingGW. Okay,
so should I set up some?
Okay, so it's detected visual studio. So what we'll do is we'll change.
So it looks like it's detected it all for you. That's really good. So we're going to move that one there. We're going to make MingGW. Now you've got two compilers available, which is great. We're going to make MingGW. Okay. Just give it a second. This should work now.
Thank you very much.
Sorry?
This lack.
Yeah. So CPP, CPP lang. So get rid of all that. Just CPP lang. That's the one. Sure. Okay, so that's all you need to install. So have you installed CLion? Okay, so don't worry, you've done that. That's all you need to do. Sorry? We'll find it and configure everything. Okay. Yeah, so if you install CLion, then when you first run it, it has this little sort of set of windows to go through where you configure it. Yeah, we'll do the free evaluation. Just to get us started today. You don't need to install So if you download it, we can adjust it. Yeah. So you go in here and we'll have to wait for Justin to get them. I'll let him know to bring up the keyboard. Thank you. Straight to make sure it detects it.
I'm quite chuffed that I've already done that.
Do some work.
It's a break, but you don't know where to go.
Excellent. Thank you. Try this exercise.
And I'm getting some.
Okay, so you're trying to print 122 characters. 0, I, 0 to 122.
Sorting out parents and child structure. That's really
So, C++ uses ASCII characters, so every character has a numeric value. I can't remember.
Okay. Okay.
So just try.
So you just like checking.
So I think the first time these characters
Oh yes.
stuff that was used for the
One, not the one with flying bubbles.
So if you yeah.
That was quite a slick page. It's got quite good something. Yeah, I'm pretty sure. That was it. Work. Yeah. That was all. That was good. Nice and smooth.
Yeah. So did you go to that web address?
No, if you get that one, very good.
I can't remember what it is now. So it's that address there. cpplang.now.sh.
Just so this made
Yeah, it's been a bit of a... No, so far we're installing, we haven't actually done anything today. Okay, just today. Yeah, we're installing a compiler and installing a compiler inside the CMake. Do you have a laptop? Yes, I do. I've already done it. Sorry? I've already done it. You powered it up. Okay, so what operating system? iOS. Sierra. Okay, right, so if your laptop's there, I can show you how to do it. Okay, show it.
No, it's interesting. I'm really interested to see what you. Show us.
Wait, who said that? Who said somebody said they would see?
No, I don't. No.
Tristan, well done. Don't let that person go.
No.
So, I don't know if you remember me saying last week, we have
I have a lot of work. I have
I'm thinking about social media. I'm just thinking how Tristan doesn't like to run the Twitter. Well, I tweet whenever I can, but I'm as far as you can say from marketing people, like, I do when I have to. Yeah. But I feel every time that I lose my soul if I do. I think I'm too geeky for that side.
Has anybody got the Wi-Fi?
Somebody was really playing on my nerves. Yeah, that's playing on my nerves.
It was here.
The frame is over there. In a polite way. Should I tell you the truth? Should I tell you what is the
That question's enough, right? The fact you're asking that question, that tells them
and he said, tell me the truth, tell me the truth. And I said, well, so I don't want to work with you.
Yeah. But it's a hard decision to make.
He started chuckling. And then the phone quite quickly cut. I don't know why. He started like,
What kind of things do you do? No, come on. More than that. What kind of things?
the network, Office 365.
Okay, cool.
firewalls, making sure the machines are running, there is no viruses, there is no crypto virus, people download stupid attachment, and they don't believe in a prince from Nigeria, even though they found a flat with just those $38 million. Yes, but I don't think they were for giveaway.
Yeah, of course they are. It says on email.
So after that was like, but honestly, if I can, I want to do, like coding is nice, but I enjoy it. So if I can do coding project in someone,
That's good. Yeah. But I'm doing similar things. So I like doing infrastructures or power migrations, that kind of thing. But I can do a bit of PowerShell, I can do a bit of JSON, XML, but that's script. This is compiling code, I've got no idea.
You see, I enjoyed IT many years ago when you found IT was solved.
And now it's like very complex. Customer doesn't want you to set a thing. They want you to come and buy a fix. And most of the time fixes are very love it.
Yeah, really?
Oh, this one was 5 years. Well, it goes like 5, but it goes to 9. With the Windows XP on it. There's a lot. Sorry, I'm happy to spend 3 hours, 4 hours probably how it should take. We'll run 10% faster. But we are happy.
And in 2 weeks we'll be shipping it.
Yeah, so
and it's not secure and all of that.
Yeah.
Wow.
So using your brain is one advantage.
Yeah, it's nice. This file is from last week, but it's 48K and it says it's corrupt. So I'm make sure we've got the whole file. I did it a few minutes ago because it wasn't going. I thought it was. So the first one didn't go at all, and the second time. Maybe someone else does it, maybe I'm doing it wrong.
Yeah, apparently your slides were
when you just did, it's 48K and it says, well,
Somebody's cursed,
it's
isn't
either me
it?
or you.
It's entirely probable it's me.
People will have to, their Windows, they'll have to put on a C drive, yes? The main C drive, am I correct? I got questions.
MingGW, no, you can put it wherever you like. They look fine on GitHub.
Oh, really?
On the website, yeah.
Oh, so it's me, okay, fine.
You can put it. You can unpack it any way you like, and then you just have to tell CLion
Okay.
where you unpacked it.
You know what I did? I think I did my save link as,
Ah.
and it says it's a PDF, but it isn't the whole
Yeah.
content. Yeah, I did,
Yeah.
yeah. But if you go into it download, you get the right thing. Cool, thank you. Usually,
Okay, who still needs more time? Yeah.
yeah. Okay. That's last year.
You're running out of space. Okay. Well, you don't need Xcode. Full Xcode is like 7 gigabytes. Yeah, my mind's already over 100 megabytes. We'll go through it instead. Oh, if you already have them, no, we'll try and fix that. Okay. You say you can.
Yeah. Slide you back.
No, for now it's just extracted. And if it doesn't, then it's just not I done that in CLion almost a year ago, and I switched it at the moment me, but I'm trying to March, but the looks and LVM at the moment, still not counting me. So they still smack me in the face and the laughing at me. So I'm trying to fix that. Yeah, I think want to.
It's based on but I got better light installation. Yeah.
How are we getting on? Everybody happy? Raise your hand if you still need time.
We've got one left.
So everybody okay, yeah? Who needs help? Anybody? Okay.
Tristan, I think we are almost to go.
Yep.
If somebody needs help, let us know. We'll try to come to you. Because majority I think is finished, so we can move on without, so we won't waste so much time.
No, we're just waiting for it to install.
Okay.
Okay. So everybody got CLion running. Been through that little thing that tells you at the start of selecting a colour scheme and all that.
Yes.
Lovely things. All right. Let's have a little look at it. If I can get this to work, hopefully. You will just to be able to share my screen. Tom, let me know if this doesn't work on the stream, okay?
Yep.
At the moment, I can see your background.
Yeah.
I'm not, so actually, I can see the display thingy.
That's not the one.
Okay, now I can
Oh,
see
how
now.
many windows have I got open here?
Oh my goodness.
All of them. Right, whatever. In CLion,
Yeah, we can see this line.
let's go for a new project. So we can select the language standard. We're going to go for 14, which is what we're using on this course. If you want to go for 17, shouldn't be any problem, but we're not going to use any of the new features. And then, so you see, it's put it in this CPP London Uni directory. That's just because that was the last one I used. It's not smart enough to know that. It just happens to be the last one I used. So we'll call it something. Session 3 demo. And then we'll click create at the bottom. And if we give it a minute. Get a lovely tip of the day.
Are we not allowed spaces and things like that?
This is a path on your file on your file system, so spaces should be all right. So it'll pop up with this nice little hello world. The first time you create a project, it starts thinking about things for a bit, updating symbols and all that, but it'll finish quick enough. He says, waiting.
It's got another 1700 to do.
Where do you see that?
Bottom right.
Oh no, that's how much memory it's using.
Oh, is it?
It's using 355 megs. If our friends at JetBrains are watching, by the way, this is a part of your IDE you could
Improve.
make work a little more quickly.
I think they improved on some of those.
Maybe it's just Apple machines.
It might be. It might be. I can hear the fans whirring as well, so it's obviously working pretty hard encoding the stream and doing everything else. Honestly, it's usually faster than this. It just knows everybody's watching what it's doing, so it's having its moment in the spotlight. While we're waiting for it, this is the main editor window. Don't worry about CMake lists.txt for now. We'll talk about it in a bit. This is our main editor window. We can type what we like in there with a very long delay because it's busy. Can mess about with things. See, it sort of tries to format things nicely as you might expect. That's we're having fun with technology today, aren't we? But eventually, all right, it's finished. And once it's finished doing all that stuff, wait for Chrome to disappear. This little play button lights up in, well, it's green on my thing. The play button might appear on the right on yours. I think my toolbar layout's from an older version. But if I click play, we'll have this little thing pop up on the bottom. And you see it's, oh, that went quickly. What it says is it's building this CXX object, linking executable, build target, and then the window flicks to run, and we see it does exactly what we wanted it to. Prints out, hello, CPP London Uni.
Can I run that or whatever it is?
So,
Kristen, sorry, for those at the back and a bit aged and can't see you. Are you able to increase the font size?
Okay.
Well, it's not.
If you go to the view, there's a presentation.
I know there's a presentation mode, but it hides all the bits that I'm trying to show.
Okay.
So if I go to presentation mode, you can see the text more clearly. But what I really wanted to show you was the how to compile things using the play button there. So if we if I just exit this for a moment,
Sorry, do you know how to get your messages tab up?
Yeah.
it's just along. It should be just along the bottom.
No, I don't see.
So down here. So this one is for, this play button is for running the program. The little ant thing runs the debugger, which we'll talk about not today, but in future. And this one here, build, Command F9 shortcut on my system. If you just click that, it builds the software but doesn't run it. In this case, I haven't changed it since it last built, so it doesn't do anything. But if I change it to something like that, and I click this build, you'll see it goes through and it builds this file again. So, having shown you that very quickly, I'll wait for an eternity for my laptop to catch up. I'll flick back over here. And this is what you need to do. I think quite a few of you have already done so. But we just want to make sure that you can create a new project, you can get everything up and running. So I deliberately did that quite quickly just to give you a rough idea, but you can maybe have a bit of an explore of CLion for a couple of minutes. But this is pretty important. I mean, this is, without doing this, you're not going to be able to do much programming at all, much C++ at all. So it's really important that we get this step right and that everybody's set up. So if you do have any problems setting a project, if you get errors when it compiles, anything like that, let one of us know. Me or Justin or Tom or your next door neighbour or anybody. Yeah.
What's clang tidy?
Clang tidy is like a, you know what a linter is?
Oh yeah.
Yeah, it like checks your source code for
Okay.
possible errors, although in my opinion it's a bit overzealous sometimes.
Oh, okay, so no.
Yeah.
Basically, we just run MingGW. We all we can use MingGW.
Yes,
Yeah.
of course, yeah. Up to yeah, so if you've still got, yeah, if the building symbol thing is still chugging along at the bottom, the little arrow won't light up in green. You have to wait quite a while for the building symbols thing to finish. That only happens the first time you open the project.
No. Okay.
Dodgy video.
Well, you don't have to worry about creating anything. I just want to ask to create a new project.
No, I don't really. It's like a very basic like JavaScript.
Okay. Yeah. CSS. Yeah.
Yeah. I don't really know. Lots of
Oh, right, so my
I've been using CLion for a long time, so my toolbar.
Yeah, I understand. I did programming last year.
It does the same thing.
It's not just jobs. It's better to type. Sometimes Android apps. Android apps. Probably get lazy.
But yeah, at the same time.
So C++.
Creating user
games.
Yeah, I quite like to get into creating games. Use the background as simple game engine. Like really powerful actually.
So is that your job?
No, I'm not working at the moment. I'm actually an engineer. I was in the oil and gas business, so price of oil being very low for the last few years. Get myself busy doing this, but I actually enjoy doing this for oil and gas. So oil and gas, yeah. I design. That's just for a tutorial.
So you just have to wait for it to do this building.
C++ is funny interesting.
I mean, just to
Just click that
to see
Windows
what
name, make sure it says hello world. If it says hello world, you're all set.
So you're not in the IT business then? Okay. What do you do?
at the moment, I give my things that
Yeah,
I'm enjoying.
It's a nice life, Jim.
Yeah.
Comes the money that's there.
Got to get used to this projector business if it's standing right in front of it.
Yeah, well, yeah, 100%. I agree. So this is the.
So how many people are still chugging along looking at the, loading symbols? Has everybody finished doing that? No? Yes? No?
Yes.
All good? Everyone's got their first project built. It said hello world. Awesome. Yep. That's it. That's the objective for the first half of this lesson done. You're all set up and ready to go. So that's awesome. Anybody have any questions? I mean, not really in detail about CLion, because I probably can't answer them. But generally, everybody's happy, raring to go.
You might mention a few alternatives, maybe why people finish to CLion.
Alternative to CLion. Okay, so there are on Windows. You've got Visual Studio, which is for people who do C++ on Windows. That's pretty much the industry standard one everybody uses. On the Mac, there's Xcode, which if you've done any iOS development, you will have used Xcode. Another cross-platform one that's quite popular is Qt Creator, particularly. So there's a framework for doing user interface stuff in C++ called Qt, and they have their own IDE called Qt Creator, which is pretty good. If CLion wasn't available, I'd tell everybody to use Qt Creator because I quite like it. And it has, a form designer and things built into there for using with Qt. And there's good old Vim and Emacs for people who like those sort of things. But having insulted Haskell users a couple of weeks ago, I'm not going to insult idiots who use Vim. So half the stream's going to drop off now. All right. Well, speaking of IDEs, let's talk about compilers. So there are lots and lots of them. So lots of little embedded devices will have their own kind of C++ compiler. And at the other end of the scale, supercomputers will have their own C++ compiler. But for general purpose use, there are 3 compilers the world care about. So the big 3. The first one is GCC, the GNU compiler collection. Used to be the GNU C compiler, but they branched out. It's now the compiler collection. On Windows, this is called MingGW, the minimal GNU compiler for Windows. So this is it's not just C and C++. It's got all sorts of compilers in there. If you download the whole thing, there's Fortran and Go and Ada, and there used to be a Java compiler. Loads of different languages it supports. And the Windows version is minimal because not all of those work on Windows. That's why it's called minimal. So if you're using Linux, this is pretty much the default compiler there. It's very good. Standard support is bang up to date. They've just released version 8, I think, 8.1, which has full C++ 17 support.
On that note, does CLion automatically, or the defaults automatically set to update automatically on releases for any update?
No, so yes, that's a good question. The question about compiler updates. So compilers release updates from time to time. We'll do it from easiest to hardest. On Linux, your package manager will update you from time to time. You know, however it usually does it, it'll update your compiler as well. It's just like any other package on the system. For Mac, if you installed it using that Xcode select, then again, it'll come through in the App Store. It'll say we've got an update for the command line tools for Xcode. Do you want to update it? Yes. Windows, it's a bit more difficult because, as you saw, all you did was unzip this thing. So for that, you have to manually go through and download the new version of MingGW, and you can delete that old MingGW directory and install the new one and unzip the new one in its place. Restart CLion, and it should just keep working. But Windows, you have to update the compiler manually. But you all got the newest version. That's going to last you through this course at least. And once you're a bit more happy with everything, you'll find that you can monitor that website for changes. If you really get into C++, you'll get really enthusiastic about the new compiler releases. Anyway, so we talked. No, really. We talked about G++. The other important one, or second one of the three, is Clang. So LLVM is the low-level virtual machine. It's what it stands for. It's this project started at a university many, many years ago. And the LLVM project powers the compilers for a lot of the new languages that are coming out. So Swift, for example, or Rust. There's a Go compiler for LLVM. And the C and C++ compiler goes by the name of Clang. This is the default one on Mac. It's the default one for doing iOS stuff. You can also install it on Linux, and there's also a version for Windows. Unfortunately, CLion can't use the Windows Clang yet. They're getting to it, but it doesn't support it yet. So that's why we went with MingGW. But yes, Clang is also very good with the standard support. The only issue there is on Apple, for some reason, the Apple releases tend to lag behind the LLVM releases, but it's no big deal, certainly not for our purposes here. Finally, on Windows, we've got MSVC, which is the Microsoft Visual C++ compiler. That gets bundled with Visual Studio, which is nowadays a free download. There's a community edition. It does eat up about 7 gigabytes of your hard drive. But if you want to, you can have this, download the community edition. It's fully featured. I think there's probably some of the hardcore team integration stuff that it doesn't is in the enterprise version, but the community version is very good. And if you do install it, then you can configure CLion to actually use the MSVC compiler. The reason we don't do that is, well, there are a couple of reasons. Firstly is that the error messages that you get from MSVC are not always as good as the other two, and also they tend to lag behind a little bit with their support for standards. So MSVC doesn't accept things that are according to the letter of the law, valid C++, and on the other hand, sometimes it accepts things that it shouldn't do, and will give you a working program. So to give Microsoft their credit, they are working really hard to catch up to the other two, but at the moment, right now, they're a little bit behind. So just to get everybody on the same page, we recommend using one of the first two. So we've talked about compilers. We've all installed a compiler. We've just used a compiler. What does one do? This is not a trick question. What is a compiler? Anybody?
Turns your written language into machine code.
Go.
Turns your written language, English or C++, into machine code.
Turns your written language into machine code. Okay, what's a Java compiler do?
I don't know. I know I'm doing it.
No. Slightly more general. A compiler takes your source code and turns it into some other lower level form. So the original very first C++ compiler called CFront didn't output machine code, it output C, believe it or not. Now people get very hung up on terminology, so people would say, oh, this is technically a transpiler. I don't know. So Java compiler, for example, what it does is it takes in Java source code and it outputs something called Java bytecode. And then this Java bytecode gets run on what's called a Java virtual machine. But here's where you are absolutely right. For C++, we don't have a virtual machine. The compiler generates machine code, instructions that execute directly on the CPU. So many languages, most languages today, I would say probably, most new languages anyway, are what are called managed languages. This means that the compiler outputs something that is then run by another program. So to give you the example of Java, Java compiler outputs Java bytecode, which is then run by the JVM. The same thing with C#, with the Microsoft CLR, the Common Language Runtime. But with C++, like C, we generate machine code. And typically, in fact, almost exclusively, this machine code that we generate is tied to a particular CPU architecture, which you won't really care about now because you're all using Intel-compatible laptops. But for example, if you couldn't take a program that you have compiled for your laptop and run it on your phone, because your phone is very probably running an ARM processor, which doesn't understand the same machine code instructions as your laptop. And the executables we generate are also, in general, tied to a specific operating system. So what this means is we can't, in general, take something we've compiled for C++ on a Mac, say, and just copy that program and run it unchanged on Windows.
Question from the internet. In what language do you write C++ compiler?
All three of the ones I mentioned are written in C++. Which, I was wondering, I was half expecting that question to come up. The follow-up question is, how on earth do you do that?
Yes.
Which nobody asked. Sorry? It is absolutely a chicken and egg situation. It's called bootstrapping, from the term from pulling yourself up by your bootstraps. Try and lift yourself off the ground by pulling at your bootstraps. Right? Impossible. Bootstrapping, which in turn is where we get the term to boot your computer, or reboot, or whatever. It's a shortened form. So yes, bootstrapping. And the answer is it's very difficult. And what you do is you handwrite in assembly something that understands a little minimal subset of C, and then you generate a compiler for this minimal subset of C, and then you use that to generate another compiler, and you gradually snowball up. But it's a very tricky thing to do.
Is that the same for the GPUs?
So for GPUs, well, we don't have the bootstrapping problem. But
you have lots of different GPUs.
Yeah, and what happens with GPUs is they have a compiler for the shader language, GLSL or HLSL, that compiler is built into the driver for your particular hardware. So that's how it works on, although yeah, Vulkan and DirectX are getting a bit fancy and letting you pre-compile shaders, but that's yeah.
So if you wrote a program, if you wrote a program and compiled it on a Mac, you couldn't share it with people who are using different operators.
No, you could share it with other people using Macs, but you couldn't use that same executable on Linux or on Windows.
It's the same way that you can't install one type of software on another.
Yeah, that's for exactly this reason, yeah. What you could do is you could share your source code and then let people take your source code and compile it for their target operating system, target architecture.
There's something in the textbook about object code. Where does that fit in terms of, you said that the compiler makes everything into machine code?
We'll get to that. That's a good question. We are going to cover that shortly. So it's the compiler's job to translate your source code into machine code. So how does it do this? The first thing it has to do is it has to check the syntax of your code. So check whether you've used the words and symbols in the right way. So if you think about, by analogy to a natural language, think about English. English consists of 52 characters, 10 digits, 10 or so punctuation marks. If I start using Chinese symbols in a English text, that's not standard English, right? So natural languages have a syntax, have a way of writing them that makes sense. So do computer programs. In fact, there's a bit more to it than that, but that's the sort of basic choice. So if you think about this, if you, in C++, forget to put a semicolon, it's like forgetting to put a full stop at the end of your sentence. And suddenly the sentence doesn't make sense anymore because it's trying to run on to the next one. So if you forget a semicolon, it's almost always a syntax error in C++. If you're very unfortunate, what you put after will make sense in the context, and then you're really in trouble because it won't tell you you've missed the semicolon. But yes, checks the syntax first, and then it checks the semantics of your program. And this is whether things make sense. So if we said, we were talking about, what were we talking about? Adding things. So for ints, we can add A and B. A plus B, if A and B are both ints, A plus B is well defined. If A and B have a different type, if they're, vectors, say, if they're vectors, a vector doesn't have a plus operator. We can't say vector A plus vector B. If we try and do that, syntactically that's okay because all the at syntax level, all it sees is variable plus variable, and goes, okay, that's syntactically okay, but it's semantically wrong. It doesn't, because vector doesn't have that operator defined. So this is checked a bit later, sort of. Conceptually anyway. I mean, in real life, these phases are all mixed together. But so that's like saying, okay, so you've used English words and English symbols, but the sentence you've tried to say doesn't make any sense. You know, nonsense sentence. Word trouser ceiling. Doesn't make any sense. Just 3 random words, right? Now, those are all valid English words, but put together in a sentence doesn't mean anything. So, if the compiler can't understand what you're trying to tell it, it will stop. It'll come up with an error. It will say, I don't understand, I don't know what you're doing. We call this a compiler error or compile time error. So, anybody who's done any sort of programming before, I've no doubt will have come across syntax errors. You know, forgetting to put a bracket or whatever. C++ is no different. In the syntax error front, we also have this notion of strong typing, which is the semantic part of it. And that lets us catch a lot more errors at compile time. Turns things that would be runtime errors in a language like JavaScript or Python, turns them into compile time errors. And we strongly prefer compile time errors to runtime errors. You will not believe the lengths people go to try and make things illegal at compile time. Illegal, that is semantically incorrect, something that the compiler will give an error to. So once you understand your program, that's what's called the front end of the compiler. The front end of the compiler deals with making sure it understands your program. And what it'll typically do is turn it into what's called intermediate representation, which is specific to the compiler. And then it'll take this intermediate representation and it will run, and I'm not exaggerating, probably maybe 100 different optimization passes, optimization phases on this, until it eventually goes, okay, now I'm going to turn it into machine code, and it outputs machine code. Optimizations can, in some cases, make your program much, much faster. I mean, a couple of orders of magnitude faster, 100 times faster than just doing the naive translation.
Is there any one of the three compilers that they all, on performance terms, they all similar?
Unless if you're really, really, really into doing hardcore numerics or high-frequency trading and that sort of thing, I believe GCC currently has the edge. But if you're doing that, you're probably going to be doing a lot of low-level SIMD coding and stuff yourself. So take that with a pinch of salt. Okay. Okay, so does that all make sense? A sort of high-level overview of what the compiler does. Yeah? A few sheepish nods. So on Unix systems, that is Macs, Linux, we can invoke the compiler directly. So if you use Linux, you probably use the command line all the time. But we can say there are a few ways of doing it in this particular example. So CC, uppercase CC is the C++ compiler. Lowercase cc is the C compiler. Uppercase CC, C is your system default C++ compiler. You give it the name of the file you want to compile, and then you do -o output my executable, which is great for little test programs. If you just want to, check whether a tiny little thing works, just put in a text editor, invoke the compiler directly, and you can also do it on MingGW if you, on Windows. Those who have installed MingGW, you can open they don't call it terminal, whatever it's called, command prompt on Windows, and change to that C/MingGW directory. In there you'll find an executable called g++.exe, and that accepts this same command line. So I was going to go and get people to do that, to just practice invoking it, but I think we've had a bit longer than we did talking about things. So I'll leave that as an exercise that you can do by yourself rather than everybody having a go at it now. But it's, as I say, it is very useful just for little test programs that you just want to test out a few lines of code, see whether it works, rather than, oh, for goodness sake, rather than setting up a new project in CLion or something like that. So imagine we've done this, right? Imagine we have invoked this. What we did is we took a source file, we fed it to the compiler, and we got an executable out. Yeah? Simple enough. most programs are not made up of a single source file, right? But this same command line that we saw there, you can actually supply multiple files. You can have myfile1, myfile2. They don't even have to be called myfile. You can call them whatever you like. You can pass as many as you like.
Doesn't matter if they're called CPP or .h or have extension at all.
You should give them .cpp.
What will happen if I have .h?
It might try and make it a precompiled header and get very confused. So, yeah. And similarly, if it's got the extension .c, it will assume it's a C file and try and use.
Okay.
Yeah. So we can pass multiple source files at once. It's good, right? Yeah.
Well, you mean when they're separate files? They're not linked together. They're not included.
No, these are independent files. And we can just list them all on the command line and give them all to the compiler in one go, and it will spit out an executable for us. But in real-world programs, real-world programs can consist of hundreds or thousands of individual source files. And we generally don't want to give the compiler 1,000 files at once, because if you make the slightest change and it has to recompile 1,000 files, that's going to take forever. I mean, C++ in some circumstances can be pretty slow to compile as it is, and if it has to churn through 1,000 files every time you change anything, that's rapidly going to contribute to global warming. So instead, we send each file to the compiler individually. And what it does is, instead of producing the final executable, it produces this intermediate thing called an object file. And an object file contains the machine code just for that one file you gave it. So you can't execute an object file because it doesn't have the right bits to tell the operating system where to start, where to begin, any of that. It's just the machine code for just that one file that you gave it. It's an intermediate file. It's usually Unix systems it's .o, Windows I think it's .obj. So let's say you have 1,000 files. You invoke the compiler 1,000 times, once for each file, produces 1,000 .o files, and then there's a second program called the linker. Collects them together, collects all these .o files together, works out the cross-references, sorts everything out, and the linker is what actually produces your executable. So if you look at it schematically, it turns into this. So source file is compiled to object file. You imagine there are more than just 3. All these object files come together in the linker to produce the final executable. And actually, if we go back to the simple case, this is happening here, except the compiler is doing the produce an object file and run the linker. It's doing it all in one step for you. So the linker's still involved here. It's just hidden from you to make it easier to use that little command on the command line. Now this has the advantage that if we don't change a source file, we don't have to run the compiler because its object file won't have changed. So if we change this source file, so if we compile our executable, we change this source file, all we have to do is go down this path. Run the compiler just for that one file, produce an updated object file. These still exist. We put them together, the linker runs again, and we produce a new executable. But crucially, we don't have to run the compiler for these other 2 files, or the other 999,000 files, or however many it may be. So this is called separate compilation, and it speeds things up quite a lot. So that's great. Libraries. Who knows what a library is? I don't mean the building with lots of books in it. A software library. Have you heard the term library before?
Yeah.
Okay, so other people, the companies, organisations, teams, whatever it may be, they produce this software. Much of it nowadays open source. There's still a big market for commercial libraries as well. So these are like software repositories that you can use. These are not programs, these are routines that people have written that you can use in your own code. And in the real world, we don't want to do everything from scratch, right? There are many, many, many solved problems. And we can build on the other people's solutions to these solved problems. We can use their code in our programs through what are called libraries. So you can take this to extremes. I don't know, who here knows about the left pad? No? Yeah, it's a library for Node that had like, it's literally one function just to left pad a string, like put spaces at the start of a string. And I can't remember what it was exactly. This code got hijacked on Node somehow, but it turns out it had been downloaded like a couple of 100,000 times just to pad the left of a string. It's ridiculous. Because it's literally one line in JavaScript. Anyway, in C++, libraries get compiled into object files. So remember, an object file is like this intermediate. It's intermediate, but it's the output of the compiler that goes into the linker. And libraries are object files. They're not exactly the same type of object file if you want to get technical. So you have to tell specially that you want to build a library, but doesn't really matter too much. They have object code in them. And we've already used one. So the C++ standard library comes with your compiler. And it's where this standard cout business came from. That's defined in the standard library. When you compile a C++ program, the linker knows where the C++ standard library lives, like the literal library file lives on your computer, and it automatically includes it. But for other libraries that we might want to use, we have to tell the compiler, or the linker specifically, where it is, where that library code is. So schematically, we've now got this. We've got all these libraries up here that get involved in the link stage. So it may be, and it happens sometimes, this bit works okay, and then you get to here, and suddenly the linker will complain because I can't find this library because you accidentally deleted it or whatever might have happened. So that can happen sometimes, but that schematically is where libraries come into it.
When I use a library, the linker is going to use only the part of the library that I need? Or?
Yeah, only the parts of the library. So if you think about it, this is a big, it's actually a static library, it's called an archive file. It contains lots of machine code. The linker will pick the bits it needs and ignore the rest. Only the bits that you need get compiled, get included in your final executable.
If you're writing source file and the object file resulting correspond exactly with something in a library, the linker will use what the object file that you created or the library. Which one will have a preference?
So if you write a function that has the same name as a function in the library,
yeah.
I believe that the version in the object file might be preferred, but technically it's either or, and it's not a great idea. Right, so it's name clashing, because then what happens if another part of the code in this library thinks it's calling, I don't know, function vector add or something. If this object file has a function called vector add and there's a library up here that defines a function called vector add, if they do different things, then this library's code is going to get very confused because it's not going to call the right vector add. So this name clashing is a very real problem, which is why we have namespaces. those fun std : things that I get lots of complaints about from the middle row there, is precisely for this problem of name clashing. So libraries, C++ libraries will almost always use their own namespace. So Boost, for example, which is a very big collection of libraries, uses a namespace Boost, B-O-O-S-T : the standard library uses std : and this allows you to have functions with the same name that don't clash because they live in different namespaces. So that's a very good question.
Are we going to go into at some point how to set up our own namespaces?
Yes, we will certainly do that.
Can you live without using the namespaces?
You can, but what you have to do then is prefix your functions with some unique identifier. So, has anyone done any iOS development? No? Oh, never mind then. This problem, so C doesn't have namespaces, and nor does Objective-C, which is how people used to write iOS code until a couple of years ago when Swift came along. And then you don't have namespaces, so you have to sort of invent them manually. So for every system function in Cocoa, which is the UI library, is prefixed with NS. So you have NS object, NS this, NS that. And it rapidly gets tiresome to write. And that's how you have to do things in C as well. And Qt, which I was talking about earlier, because it's from the Stone Age and dates from a time before, like literally it's 25 years old, it dates from a time before C++ had namespaces, it prefixes everything with a Q at the front.
Tristan, I have two questions.
Just got one at the back. Yeah.
So I was trying to do the homework.
Yeah.
The homework refers to a library called stdfacilities.h.
Yes. So that's it's on a website that accompanies the book. I can't remember the URL off the top of my head. It is somewhere in the introductory chapter, but Tom actually told me about that last week. And what we'll do is I'll take a copy of that and put it on our GitHub as well, just because a lot of the examples in the book assume you've got that. So I'll make that available on our GitHub as well.
The file. Yeah.
That .h file off the shelf is not compiled. Because I guess it is written, if you look at it, the last revision is April 25th, 2010.
Okay.
If you go to the book, yes. If you read chapter 1 and 2 and 3, I think in chapter, I'll give you some homework. Chapter 2, they list, Mr. Strasser lists the name of the file, where you can find it. The file exists there, and on the following page, even lists you what's inside that file.
I'll just put it on Slack.
How is that related to my question about
There's
because
also
it's from 2010. It does not compile as it is.
Yeah, I have to be honest, I haven't tried this far. What I'll do is I'll try it out, and if it needs fixing, I'll put up a fixed version on the GitHub that works with modern compilers. I'm quite surprised that it doesn't.
if you go on the website, there is a link where you can where they explain you how to compile with Visual Studio 2017 or whatever.
Okay.
And they give you the exact file, and it tells you where you have to put the file and everything. There is a link on the website of the
authors. Yeah. Yeah.
I have two questions online. The first one is, so how the linker so the linker is within the compiler. Is the linker within the compiler?
It's technically a separate program, and you can run it separately. It's called LD usually. So you can invoke it separately, and you can do it on the command line if you really want to. You can give it a list of object files, and you can tell it the name of the executable. What happens is, if you do the all-in-one compile step, the compiler knows about the linker, so it will run the linker for you, so you don't have to do it manually.
Okay. And
Second question is, how does the linker know the order? I suspect how to order add the files.
Because you invoke it on the command line with the files. So it generally doesn't matter what order. These are supposed to be independent files, independent compilations, so it doesn't matter if you give the compiler multiple files at once, that's fine. The ordering of libraries can matter. If library A depends on library B, and then you use library B, then you also depend transitively on library A. And then it can matter the order that you give it. But generally, you don't have to worry about that unless you're invoking things on the command line. If you use a build system that we'll talk about next, usually that'll take care of getting the ordering of things right.
Are the macros bypassing something to compile, or is it
Macros are... I did a slide on macros and then decided that was getting a bit too deeply into things, so I took it out. But macros are part of what's called the C preprocessor. So anything that begins with a hash, that runs as part of the preprocessor. So we had that compiler. I told you about the compiler. You know, it does a syntax checking, then it's a semantic check. Before it does any of that, an entirely separate programming language called the C preprocessor language scans through your source code and looks for any command beginning with a hash. And this allows you to do textual transformations. So you could, it's a macro language, so you can replace pieces of text. The C++ preprocessor doesn't know about C++, doesn't know about C really. All it knows about is text, and it's just for manipulating the text of your program. So the preprocessor, so the macros run, to answer your question properly, the macros run before the compiler even sees the source code, which is a long time before the linker sees the object code. So the preprocessor is step 0, if you like.
Am I correct in saying that macros are not very liked by C++?
You would be absolutely right in saying that macros are despised, and we want to get rid of them, but unfortunately they're still very useful for things, not least including other files. Did you have a question? You look like you are... No? Ah. So this is our sort of compilation model, if you like. This is where we've got to. We've got lots of source files, potentially hundreds, maybe even thousands of them. We want to give each one individually to the compiler. The compiler will produce an object file. The linker will take these object files together with external libraries, and it will generate our final executable. And that's great, but it's a lot of work and very tedious if you're going to try and do this manually using the command line all the time. It's possible. It's entirely possible if you've got the patience. This is not the way things happen in the real world. Well, this is how things happen, but people don't do it on the command line. What they do is they use a build system. So if you've used a compiled programming language before, you've probably come across some sort of build system. Right, so I don't know if anybody done Java, C#, bit of Java, yeah. C#, it's Java, yeah. So what's the newest one now for Java? Is it Gradle? They're still using Gradle? Yeah. Do you like it?
It's okay. Better than Maven.
Yeah, build systems are universally loathed, right? I don't know why. They're like the most hated piece of technology by anybody who does any sort of programming. It doesn't matter the language. C++ developers hate the ones they use. Java developers hate the ones they use. I don't know.
They're quite a black box, aren't they?
They are. A lot of it's a black box, and unfortunately...
Jason Turner got a saying about CMake, which is for C++ for JetBrains. This is a tool, this is the language everybody hates to love to hate. Sorry.
It's just, if something goes wrong, it's really hard sometimes to find out where it's gone wrong. It's
And
error logs.
so build systems do a very important job, despite being hated. They're very useful, because when you edit a file, the timestamp on that file changes. When you click build, it looks at the timestamp, it looks at the files that have changed, it recompiles only those files. So it saves a lot of work, a lot of effort. There are lots and lots and lots of build systems. MS Build is the Microsoft one built into Visual Studio. There's CMake for Linux, which if you've used, I'm sorry for you. There's WAF or WAF, it's a Python one. Scones, Meson is a new one that a lot of people have said is quite nice for a build system.
Why does everybody hate them universally?
I don't know, because...
Yeah, weirdos.
Because to be useful, a build
system... them sound very, very...
No, it's what you said. John, it's what John said. They are often a black box, right? So to be useful, a build system has to have a lot of options, because you want to be able to use the same build system on Windows or Mac or whatever, or on iOS or whatever you're doing, and so it has to give you lots of options, and you have to be able to configure it. So you have to have some sort of scripting language to be able to configure your build system. And so this is like a sort of second programming language you have to learn, or you have to not learn, you have to know enough about in order to be able to use the first one you actually want to be using. And it's, as I'm sure all of you will do, when you first learn a new language, you curse it because you think it's really stupid. Why does it do this? Why does it not do it the obvious way to me? Because that's really stupid. And then once you've been using it for a while, you become comfortable. Maybe it's Stockholm syndrome. You go, well, actually this way makes sense. And why this other language over here? No, this is doing it in a stupid way. Build systems, I guess, are a bit like that, except without the Stockholm syndrome. There are very few experts in them. People learn, I mean, on a case in point, you learn just enough to do what you need to do.
It took me 8 hours to configure first CMake 4 when I was trying to play with Boost. So I was trying to set up. After 8 hours, I was just really desperate to run the first tutorial.
Now Stockholm syndrome kicked in and you love it, or you need to...
No, I still am ready to jump out of the window with a scream.
So, yes, CMake. CMake is probably the most common build system for C++ projects. Certainly it's by far the most common for open source C++ projects. Someone counted, I think, 90% of the C++ projects on GitHub use CMake. Most C++ code is not on GitHub, of course. Organizations, a lot of them right around us right now, the one we're in right now, they have all this proprietary code. And lots of companies do have their own proprietary build systems, which are probably hated just as much as the public ones, but there we are. So CMake is the one we'll be using. CMake is widely supported by IDEs. The newest versions of Visual Studio understand CMake. Eclipse, if you use Eclipse, that understands it. Qt Creator that I mentioned earlier, and in particular CLion understands CMake, knows about CMake, which is great because it saves us from all the pain of having to manually write the scripts to configure the build system. We don't have to do that. We're not going to have to worry about compiling our example programs for a different operating system or anything like that. We're not going to have to use any of the difficult but technically possible things you can do in CMake. We're going to be using the basics, and CLion can manage the basics very, very well. So we will rarely touch CMake itself. But if you're curious, if you look in the project, if you've still got it open, there was this file, cmakelists.txt, and that's the configuration for the program. So if you really want to, you can have a look at CMake list. You can edit it if you like. And there's also the CMake website, I think it's CMake.com or CMake.org, has extensive and possibly slightly out-of-date documentation.
Where does version control fit in? You mentioned that there's not a lot of C++ code on GitHub, and I can understand possibly why. But what about, do people use Git or do people use something else?
No, I didn't say there wasn't a lot of C++ code on GitHub. There's quite a lot of C. It's just that most C++ code is not on GitHub. Most.
Yeah, that's what.
Yeah. Yeah.
It just got me thinking about that.
So version control, again, this is organizations will have their own way of doing things. Most organizations, I guess, these days are probably using Git. It seems to, it's taken over. 5 years ago, it was a bit different. Nowadays, almost everybody's using Git. It started out as, something you probably know, started out as this version control for the Linux kernel. And nowadays it's used for almost everything, and GitHub has taken over our lives. And yeah. So there are others. There's Perforce, I know, is one that gets used quite a bit in big organizations. But yes, Git is where it's at. So.
I'm just thinking about how organizations manage teams of people building code without, or not without, but what do they use?
Yeah, and this is a challenge. So I was just a presentation from a C++ conference, because I'm a really interesting person who watches conference videos on YouTube. Right? But there was one from a chap at Google, and they have all their code, and I don't just mean all their C++ code. I mean all their code in one gigantic Git repository, and this thing is hundreds of gigabytes in size. It is enormous, and the talk was about how they had to engineer Git and how they had to make changes to it in order to handle this, because I don't know how many people work at Google, but it's going to be in the tens of thousands of people all trying to commit changes sort of simultaneously, and it's a massive engineering challenge, definitely. Not necessarily something that's C++ specific. I mean, that will apply no matter what language you use. If you're doing things at that scale, things get tricky. So build systems, yes, if you've used a compile language, you will have used a build system. The one we're going to use is CMake. But don't fret about it too much, because CLion will handle most of it for you. Sound reasonable?
Which level of seniority do you think we should be decent enough to be able to manage a build system?
Which level of seniority?
Yeah, assuming you go for, I don't know, mid-level position and you are expecting...
It certainly wouldn't be a disadvantage if you're in an interview and they say, you know, do you know about CMake? Yeah. You say, yeah, of course I do. Yeah. Of course, it's not a disadvantage. But having said that, a lot of companies do use their own internal build systems, or they'll use ones that they've customized in various ways. So if I was an interviewer, somebody not knowing the build system, not knowing a particular build system wouldn't be a deal breaker, because it's something that you can, as I say, learn enough about. You learn it enough to be productive, to know how to add a new file to it or something, or to. Which is,
it's like a Git. Everybody pretends to master Git, and then in each company you have someone which is.
Yeah, it's exactly like Git. So for Git, what do you really need to know how to do? Commit, check out, revert changes, maybe. Rebase, yeah, push. There are probably half a dozen Git commands you really need to know. And it's the same with at least my level of CMake. You know, there are 1,000 options, and I probably know half a dozen of them, but it's just enough to get done what I need to get done. Right. Let's move on. Header files and implementation files. So, each source file, each .cpp file that we write, is processed individually by the compiler. This is a problem, because generally we want these files to be able to call functions between each other. So if you've written a function in file A, you want to be able to call that function from file B. Right? If I defined my type, if I've got a type that I want to be able to use in multiple files, how do we do that? So in C++, at present anyway, we use what are called header files, or just called headers. Headers are also source code. They are C++ code. So sometimes people don't like it if you call them source files. So sometimes we'll talk about header files and implementation files. When I talk about an implementation file, that's one that actually gets passed to the compiler, directly to the compiler with the .cpp extension. As our header files, we use .hpp in this course. Some people use just .h. .h is also used for C header files, so that's why I prefer the HPP. So header files are pieces of code that are shared between implementation files. And a header will generally contain the declarations of functions that we want to call. So if you remember, we can separate a function in C and in C++. We can have a declaration and then we can have a definition. And they can be separate. And the whole reason that they can be separate is so that we can place a declaration. We can say, this function exists in a header. And then we put the definition, that's what does this function actually do. The definition goes in a different, well, goes in one implementation file, but the declaration goes in a header which is shared between multiple implementation files.
Is the header file compiled? It's not compiled.
Not directly, no. So if you think about this, I didn't draw a new version of this because frankly this took me ages to do. But if you think about it, over here we might have some header files. And these source files, multiple source files might use one header file. So the headers don't get passed to the compiler directly, but in fact they get included in this source file. So, remember this is the other thing I said a couple of weeks ago. In order to be able to call a function, the compiler needs to have seen its declaration. Needs to know the signature of this function, the name, and how many arguments it takes, the types of the arguments, what type it returns. And all that's contained in what we call the function signature, function declaration. So what we do is we place the declaration in this shared file, and we place the definition in just one of our object files. And then what happens is that later, if we have the definition of a function in file A and file B calls this function, they're both independently sent to they're compiled separately. Remember, that's that diagram of things happening in parallel. They're compiled separately. So file A contains the definition. That gets compiled, that's fine. File B, it doesn't know the definition of this function yet, but it knows the signature. So it inserts, in the object file, it inserts a message saying, call this function with these arguments. And then later on, the linker, this is what the linker does. It links together your object files. So it looks for your function calls and it matches them to the code that implements that function, which is probably in a different object file. Everybody was nodding and going, okay, this is really easy when it's all just things happening in parallel. And now there are...
Does it matter which order you pass in the header files, source files,
It can do, because an implementation file might depend on a header which depends on another header and assumes that you've included that one first. We'll see an example in a moment that may or may not make it clearer.
Does the linker does the linker repeat or copy the function in every single place it's called, or does it?
No, the linker takes one copy of every function.
Okay.
It's putting together lots of files. Why does it matter? Why would it compile the one functions there? So like when you're compiling one.
So I go back to that nice diagram, that one. Yeah.
So if you're compiling one file,
yeah,
and you have a function below the main, then it won't do it. But then surely if you've got a lot of other functions up there.
Okay, so this is the thing that in order to be able to call a function, we need to know its declaration. Okay, and the declaration has to have appeared physically above where we're trying to use it in the source code. So the compiler reads source code left to right, top to bottom, and so the declaration has to physically appear above where we're trying to use it. Right? So that's why they're called headers, because they go at the head of your source file. And so you write all the declarations first, and then you use those functions underneath, or define them. Now, what you're saying is, when you write a single source file, you do your main, and then you write your functions underneath. And why doesn't that work? It's because at the time you try to use them in main up here, the compiler hasn't seen those functions. So what you can do is either write the declaration above and the definition underneath, or move the entire definition up there. Because a definition is a declaration. Because it has that same first line. So if you remember, a declaration is void or in type function name brackets with the arguments in. And then if it's a declaration, you just put a semicolon and finish there. If it's a definition, you put the curly braces and you tell it what to do. So it is one of these things that Stack Overflow people like to bark at you when people talk about declarations being different from definitions, because a definition is a declaration. Yes. Don't worry, I will slip up and...
Are there any conventions? You mentioned that you can put your function, let me get it right, your function definition in one of your files, and as long as you have the declaration in all the files that it's used before it's used, that's fine, you can use it. Are there any conventions, again, from a kind of team working point of view, me thinking about how do I know where to go in the massive source code to actually see what this function does? Is there any conventions?
So the convention is that a file, let's call it, I don't know, file1. File1.cpp will have a matching file1.hpp. So the naming scheme, you'll have a source file, an implementation file, and a corresponding header. And the header contains the declarations, the reusable declarations, and the source file contains the definitions. And the naming scheme is that they generally will have the same name and with either .cpp or .hpp.
If I have a header file 2.hpp with one of the functions from and a file 2.cpp, and the header of the file 2.hpp has it has one of the functions from file 1.
A declaration.
How do I know if I have a file 3, 4, 5, 6, 7, 8 to go to
Because
file 1.
you wouldn't do that, because what you would do is if file2.hpp needed to use anything from file1.hpp, it would just include that header. It wouldn't redeclare it in there, because headers can include other headers, which we'll see in just a moment.
Okay.
This is really messy, and it's horrible in an awful lot of ways, but on the other hand, it's worked for like 40 odd years in C as well, and it's messy and horrible, but
that's what I was asking about conventions, because it does seem like it could get very messy very easily.
yes, yeah, it absolutely can. Where did we get to? Header files don't just contain declarations of functions. When we define types, when we define our classes, we'll put the class definition in the header. We also put templates, function templates, class templates, put those in headers. We have things called inline functions that go in headers. We'll get to those later in the course. It's not just function. In C, it's, well, you put structs as well sometimes in C in your headers, but it's not just function definitions. There's all sorts of things. That's why people sometimes go, oh, well, headers contain source code as well.
I have a question.
Oh, sorry.
So if you have a full.h,
Yeah.
and then if you have two classes that need to include full.h,
Yeah.
so two C,
Yeah.
those need to include. Is there a chance you get into a compiler error saying that full has already been declared?
Yes. Yeah, so the question is, can you get into a situation where the same header, I think what you're asking, the same header is included multiple times, and so things get multiply defined. And that is actually a big deal. And we'll talk very shortly about how to fix that. But first, the way to include a header is we said the preprocessor, things that began with a hash, are preprocessor commands. Remember, the preprocessor only knows about text. So what hash include does is it literally, nothing fancy, it literally copies and pastes the entire text of the header into the top of your source, or into where the include command appears in your source file. Literal copy and paste of the entirety of the header. So we give it the file name. If it's a local file, as they say, if it's part of our own project, we put it in quotes. In quotes. If we're using headers from other libraries, they go in angle brackets. So when we included things from the standard library, like IOStream and string, we put it in angle brackets. So what happens is when you, let's say a commercial library, you pay for it, you buy it from whoever's selling it, they will typically give you the library code file, the object code file, and they will give you the headers so that you can use this code. And the headers will go in some system location. Is it user /user/include is the common one on Linux. And these angle brackets tell the compiler, okay, look in the system standard location. Whereas the quotes say, just look in my project, because this is a local header. This belongs just to me. This isn't a library header.
Does that just look for the? Does that look in down the directories or folders?
This one?
Yeah.
No.
So it has to be in the folder.
Yeah, but you can proceed this with ..
Okay,
slash. Yeah. And you can also, you can tell the compiler, and the build system again usually handles this, you can tell it what are called include paths. So you can tell it where to look for header files.
Oh, that's fun. So I just said this, hash include performs a literal copy and paste. And header files can, they usually do, hash include other headers. So if you've got my header.hpp and it contains the declaration of a function that uses a string, you have to hash include angle brackets string, the standard library string header, in your header. So, and that in turn probably hash includes other headers for things that it relies on. So there's this cascading effect. And everyone is literal copy and paste. And the end result in this is that there's a particular command line to do it, but if you want to, you can output the result of the preprocessor. So you can output it after it's done all these includes of includes of includes. And what you find is that your little hello world program with about 4 lines, what the compiler sees is about, I think at the last count, it's about 10,000 lines of C++, because it's included. Yeah, that's why we don't want to send hundreds of files to the compiler at once. Why we want to compile everything separately if we can. But this is what you were asking at the back. We need to ensure that a header is included only once, because if we, the rule in C++ is something called the one definition rule. If you can't guess what it says, every name that we use can only be defined once. So we can declare a function as many times as we like, we can only define it once. Now that's okay because function definitions usually go in our source files, but type, if we're declaring types, that is classes or enumerations or whatever types we're using, those are usually defined in header files. And if we try and define something twice, we get into trouble. So it's very important to make sure that each header is included only once in a particular implementation. And since we're recursively going back, it's possible to get into a situation where file A includes file B and file B, and we can get into a nasty situation, potentially get into a nasty situation where the same text is copied and pasted twice in our implementation file. And that'd be bad.
Sorry, does a compiler have some kind of algorithm so that to detect a cyclic code or errors or something?
It will detect cyclic. In fact, it just won't work.
So we get an error or warning?
Well, no, because we have these things called include guards. So include guards are an include guard is this little command that says, if I've already seen this file, ignore it. Right? It's actually yeah. Well, an include guard is usually just one if-def. There are nasty ones that you use for doing other things within your file, but the include guard, we say, if we haven't defined some random name, if the preprocessor doesn't know about some random name, preprocessor programming language, you can define variable or define names. If we haven't seen this name, copy and paste this text. If we have seen this name, skip everything that occurs in this header.
Can't you just put all your includes in one file and just have reference it back to it?
That would be another way of doing it. The problem with that is that, as we were saying, for very big projects, you can't possibly know what header file somebody else is going to need.
Yeah.
And it also, like we've said, because it's a textual copy and paste, if your 1 mega include has 100 other under headers, which in turn might use other headers, that's going to expand to hundreds of thousands, millions of lines of code that the compiler then has to churn through and ignore most of, but it still has to look at it and check it and make sure it's syntactically correct.
But only if you change it. Otherwise it won't.
No, because header files literally copied and pasted into our implementation file. If there's any change in the implementation file, that entire file goes to the compiler again. To get around the nasty if-defs, there is this, I've said it's a compiler-specific mechanism. That's because I'm afraid of a backlash from the internet. If I tell you to use it, use it, use it. It's supported everywhere. It's not technically part of the C++ standard. It should be, but it isn't. But all the big three compilers that I mentioned earlier, and in fact, any compiler anybody cares about, has this thing, hash pragma once. That's a magic command. You put it right at the top of your header file, and it means include this file only once. Hash pragma once. Brilliant. Gets rid of this whole cyclic dependency problem. Stick it at the top of all your header files.
So that stops multiple declarations, does it?
It stops the same file being copied and pasted twice. So the other way is the traditional include guards and CLion. If you tell it, I want, please will you generate a header file for me, it'll stick the include guards in there for you. So again, you don't have to worry about it. It doesn't use pragma once, it uses include guards instead, but the effect is the same. So, can have a bit of a sit down. See if we can get this working again. Right, so this is my CLion window.
If you can't see, yes, try to open the YouTube. That will give you a little bit bigger view.
So we've got this sidebar, it's hidden at the moment, but if we click on project, it opens the sidebar. And if we drop that down, we can see we've got main, this is the CMake text I was talking about. This is the CMake language. You can probably guess what most of those things do, but we won't talk about that too much now. We've got this folder, CMake build.
Just a second. Anyone feels hot in the room?
Yes. It's pretty warm.
What shall we do about that?
Well, we're finishing in 9 minutes, so it's probably not worth worrying about it now. But what we can do is if I go up here and I right-click, I can go to New, and then C++, C++ source file. And if I click that, I get this nice thing pop up. Call it example. And what we'll do is we'll create an associated header.
So where did you go to?
So right-click on here. There are other ways of getting there, but this is, I can't remember, there's a shortcut for it as well.
Make sure, I think you don't send on the CMake build.
Not on CMake build, no.
Yeah, it gives you the same menu, but it will hide the files inside the
Make
CMake
sure you're on the
build.
top level. I've called it session 3 demo, but you would have given it a different name. So in here, go to New, C++ source file. Create an associated header. Add to targets just means we want to build this file. We want to include it in our CMake configuration. This is the part I was telling you that CLion basically looks after the CMake stuff for you. This is what the add to targets does. It says we want to build this example.cpp file as part of our project. So we do that. You can change the extensions if you want, or configure what they are. .cpp.hpp, I think I might have changed the default. The default might be .cpp/.h, I can't remember. Yeah. It doesn't really matter. I prefer, as I said, I prefer .hpp, so I think I changed the default, but there we are. And then what it's done, it's got to load symbols again. It's created a file, example CPP, created by me now. And all it does is it hash includes our header. And if we go to the header, I can't remember how, there's a shortcut for it. Not that one. Nope. I'll have to give up on the presentation mode, I'm afraid, because I can't remember the keyboard shortcuts. And our example HPP is empty. So these things, this if and def, if not defined, this string, then we define this string, and then we have the end if at the bottom. So that's what these are, things called include guards. And the important thing to know is that the code you write goes in the middle here. So we'll write a definition. This is a function definition.
Control out, I think,
Okay.
arrows.
So what's the return type of this function?
Favorite one.
Nothing, void, absolutely. How many arguments does this function take? None, yeah. Everyone's done their homework, literally. Excellent. And now we'll flick over to example.cpp. And in here, I'm expecting it to autocomplete for me, but it's not. So in here, we'll do this. You see, it's telling me I don't know what this is. That's why it's appeared in red. If I select it and hit the right keyboard, shortcut.
That's a useful thing about CLion. It will suggest which libraries you might
Yeah.
need to add.
It knows that if I want to use cout, I had to include iostream.
And then you have the two arrows next to void.
Ah, yes. That's a very good one to point out. So CLion's pretty smart. So I can press those two arrows and it will flick between the declaration of this function and the definition. So if I change this function now to add an int, sorry, is there a question?
Presentation.
Yes, I'll try. Trouble is I don't know how to flick between the windows.
Control Alt and or Command Alt and arrows.
No.
That will work. Go to navigate. And then
Control, Command. Oh, it does work. It's just very slow. Right. Anyway, so we've changed this function signature now. So now it's a different function, so we can't flick. If we remove that again, change it back to what it was, you see we can flick between the declaration, which is in the header, and the definition, which is in the C file, which is in the example.cpp.
One question about where to find things.
Yeah.
Yeah.
We open main.cpp somehow. So this was our main file. What we'll do is we'll delete that. And instead we'll call, what do I call it? My function. My function. Ah, well, it's red.
anybody know why?
Exactly as it said. Do I want to include it? So I'll hit the shortcut, and you see it's included the file with the declaration in main for us.
That's a very, very useful thing, especially when you learn. Like I found it at the beginning when you don't know exactly what to put where, why it goes there. This is so amazing because what you do is like, the ID supports you. Later when you know it's not a problem, it helps you. But at the beginning, it saves you hours.
See which one, sorry? Okay.
Okay. So you don't need to include IO stream in main CPP?
No. Yeah.
But that's been taken care of because you've got the guard switched on.
So I'll just be with you in a second. I'm trying to fight with this presentation mode. So the example.hpp you wanted?
The main CPP.
Sorry, was it the header? Yeah. The pragma once, no, because when I generated this file, CLion generated the include guards for me. I didn't write these. It did it for me. Now, if I wanted to, what I could do is delete those, and do hash pragma once like that, delete that line as well, and that has the same effect. It's a bit nicer, a bit tidier. But CLion puts the include guards in for you.
Same timing, compiling, no change whatsoever?
No change, no. It'll be exactly the same, yeah.
I wonder why they put it in
Sorry?
Then I wonder why they put it in a semicolon, why it's not just a pragma one.
Because on esoteric systems, on funny file systems, it can be very difficult to know exactly, yeah. There are reasons for it, but you won't run into them using a normal everyday computer.
Like if you build software for microcontrollers?
Not even that. If you're using like a VAX machine from 1982, something like that, yeah. Okay. So let's create a namespace. We're going to go a little bit over because I was just going to show you that was pretty much the end of the demo. But to do things properly, you're absolutely right. So we open a namespace by saying namespace. Apparently it doesn't like how it's spelt CPP London, but that's what we're calling it anyway. This is in the HPP file. This is a bit of a problem with the presentation mode. It doesn't show you the name of the file. It is full screen. Where do you want me to go to? No, distraction-free modes just gets rid of the Chrome.
Okay.
Yes. So sorry, this is example.hpp. We've got namespace CPP London. Within the namespace, we open the namespace with the curly brace. We put the declarations or the definitions of things that live in this namespace here, and we close it again, there. Now do you notice that little arrow has disappeared? Because this is now not the same function as this one we've defined over here. Because this one doesn't exist in a namespace. This is what's called the global namespace. So what we have to do is, well, one way of doing it is we can add a matching pair.
Namespace.
Oh yes, sorry, namespace. A matching pair in there. And now the arrow's got back, and now I can flick between these things again. Not like that, like that. But now what happens if we try and run this? So I compile it, press play. Oh, use of undeclared identifier my function. Did you mean CPP London : my function? So we click on this. It takes us to the place where the problem is. The problem is this function isn't called my function anymore. It's changed its name. Huh.
It does that.
Yeah. And now I've got CPP London my function. And I press play, and it says hello everyone, which is exactly what I told it to do here. So it all works. Or it doesn't work.
Or it doesn't work, yeah. I know before, even before going to that,
You're right. Are you itching to go? Oh, sorry. I didn't know whether you're hovering by the exit or hovering by the pizza. That's what it is, isn't it? Right, that's about all we've got time for, which is good because it's, well, it's not good that it's all we've got time for. I'd rather stay and talk all night. But it is the end of the session. It is actually all I prepared for this session as well, so that's worked out pretty well.
Could you put
you can get rid of that
PDF this example?
Well, actually, what I was going to do, had we had time, if we had 10 minutes at the end, I was going to get you to do it. But I can leave this, hopefully, as an exercise. So pretty much just do exactly what I did, except instead of my function, you have a function called add. But otherwise, if you've just been sitting there doing what I was doing, you should find that pretty easy. What? No, I didn't get as far as anything in the book for next time. Because we still haven't covered all the things we talked about last time.
Okay, so but should I ask you to read something for the, like, for the newsletter? Okay.
Yeah. So that's it for today. Next time we're going to talk about the things we didn't talk about last week. Value semantics, object lifetime, basic control flow, if statements, loops, and if we run out of time doing that, I'll come up with something more. There's a lot more to go yet. But now we're all set up, we can start writing proper programs, proper examples, we can get to the real fun stuff. So thanks everybody for coming, that's the usual slide.
Thank you very much for Christian for his time, even though he was under the weather, he done great work. This session was quite intense, like on listening, maybe it was not the most interactive, but you need to get some knowledge and have the tools. Now we have the tools. So the next session will be way more interactive. Now, we are going to Shanke. You're very welcome to join. And if I could ask everybody to give us a bit of help, because we need to rearrange a little bit of the place back to put to the normal, because that's normally like a conference room. If somebody can help maybe two people to three people stay behind and help me to that would be appreciated. And if you could make that we don't leave any rubbish, that would be really cool. And obviously I will send you email once I manage to churn through, and then you'll get it. And hopefully see you on Tuesday.
And also give me your passes.
And return passes to Justin. He's raising the hand.
Just want to say thank you again to Justin and to Mimecast and to Ollie, who's not here but did remotely help organise all of this. We do appreciate it. As soon as we know where we are for next week, we will let you know. Sorry that it's...
Next week I think it's Mimecast.
We are at Mimecast.
I think it's Mimecast. But I will send...
Last time I said to these guys, we're definitely here next week. It was wrong. So I don't want to promise it.
I mean, I will tell you exactly.
Watch this space. Tom will email you. Sorry we're making you jump through hoops. We're trying to get it sorted.
Skills matters.
Yes, skills matters.
Next week.
22nd, yeah. So it's on the skills matters. Yeah.
It's had it
22nd, 29 is 20, and then it should be quite a few next month.
Yeah, I think you can actually sign up.
Yeah, you can sign already for 2 or 3 of them in there. Sorry, is it possible to just see what I've done here? So it doesn't seem to be working nice on this important stuff.
Okay, so if you go to your example page, yeah. So
Very strange. Thank you, it's very interesting.
Yeah, sorry, that's
Thank you. See you next week.
I don't know
What did you have to do?
It looks okay to me.
Sorry?
What did you have to do?
I'm not sure if I can disclose.
Oh,
I'd love to.
No,
I'm
it's
not
not.
sure if I can.
Do you get to choose or just get in it?
No, there was one project, and everybody were doing the same project.
Oh, okay.
Yeah.
Yeah,
But
yeah.
you have to ask Tristan and Ollie whether we allow
It probably wouldn't mean anything to me otherwise anyway.
I mean, project is do something. Yes. We
Yeah,
build
yeah,
a program that works, and you know how to explain how it works.
Yeah, yeah, sure.
I'm not a committee member.
But Miss Justin is the.
Justin's the young guy who works for Mimecast who. So we're very grateful to Justin for Bruce.
Sorry.
I really enjoyed it. And, yeah, and the thing is, if I do some homework that you have my
Sure. Yeah, sure. I'm trying to diagnose a problem. Something is not
No,
working.
if you go on the internet, I think you can find, instead of just downloading that from the book, you can find files in that form. Yes. Place that header. It works for me. It works for me. If you have a search in Google, you can find place files. You can find a list of headers you can just paste in and it works. Yeah, but it's not. I think it's IO stream vector.
So you go to the main.
So that works okay. So now we're going to put in the namespace.
Because the main program, the main loop is this function called all. But here you're saying you have another function. So you have
No. You can. I'll show you that. So if you try this, okay, so now the problem is here, it's the one I just showed on the screen. So we've put our code in a namespace. But one thing we can do, so this is what you were just saying.
Yes, my function, and then you can set any code.
So using namespaces. Well, it doesn't know what that is. So it says, do we want to? Yeah, we do.
Basically, we
New namespace. So just do that. And those that fall in, now these have gone from red to white. Now, that's one way of doing it.
There's a rule.
Yeah, so another
And
way
I
of
say,
doing it.
let's start.
The best way of doing it, really.
There's no connection to you. So you don't know. Yeah.
So this is a version of my function that's in this list.
Yes. No worries. Guys, what we need to do, whoever is ready to help me, we would have to create these tables into like, one table is like this and the rest table like this, and the last table like that. Yeah?
To make
So we
sure
create
that,
like a conference,
next
put
time
chairs
we get
around, and park the rest of the chairs on the side on the wall. So volunteers needed.
So Tom deals with all the admin side of things. So he sends the emails out. He's got the email addresses.
Bit of a mistake.
Yeah.
With coming here today. I had a difficulty to find the place. For some reason, I got the confirmation yesterday.